Good afternoon, everyone. Welcome to the School of Information Studies FYI series. And in this afternoon, in the next hour, I will spend the time with you to introduce the area I'm working on. The title of this talk is GIS Mapping Your World. And it's really my pleasure to spend the next hour with you to discuss about GIS. For some of you, if you never worked with GIS or if you don't know what exactly GIS means, it's Geographic Information Systems. And in the next hour, I will discuss in more details about what it is and how it can do in our everyday life or in our research. If you have any question, feel free to stop me at any moment. Don't hesitate. I'm completely open for any discussion or any question. Feel free to stop at any moment. My name is Nicole Kong. I am an associate professor specialized in GIS at Purdue Libraries and the School of Information Studies. And it's really my interest to work in this field, and I'm always thrilled about every development of GIS. So if I talk too quick, if I talk too much using the terminology in the GIS world, feel free to stop me. So what is GIS? As I explained, this is called Geographic Information Systems. By the definition, it's the science of computer systems that collect, store, manipulate, analyze, manage, and present the geographic or spatial data. It's a quite cold definition. Maybe doesn't make too much sense to you if I read this loud. But in general, when I introduce this to somebody new to this field, it's basically a digital mapping technology. It handles the digital spatial data from the beginning, how you collect the data, to how you store, to manipulate, analyze, and until the end, how you present the geographic data. It's the whole process using the computer system. And it's one of the fastest growing fields in information technology. As you see in our everyday life, actually, you are already using geographic information. If you're expert here, you know the detail. If you're new, if it's your first time to hear about geographic information, here are a couple of examples of how geographic information can be used. On the left side of the screen, it's a screenshot of a mobile device. If you need to travel to a certain place, nowadays, I guess most of you are used to search where it is, how to drive there, what's the routing, which route you should follow. By using this, you are already using the geographic information. And in the middle of this screen, it's something probably you can see every day from the TV, from the weather forecast about what's the temperature in the next few days. People start to use digital maps to do this weather forecasting. It really gave us a really vivid interpretation of how the temperature will distribute around the nation. And on this corner, it's presidential election results. People are using maps as a way to communicate the results. And in all these instances, we are using GIS or Geographic Information Systems to present the data, to store the data, to communicate the data. That's why I say it's really a growing field. Nowadays, in a lot of news reports, you might see a map can tell you a story of whatever topic they choose. More and more people are using maps, using GIS. And in the most common way, probably you are using Google Map or map app on your mobile device. But more comprehensively at the back end, It's really a well-designed computer system. Sometimes involves a web-based interface and a computer server backend to support the whole process. And now, since the COVID-19, probably, I guess, most of the participants have seen this dashboard already. It's developed by Johns Hopkins University. People start to use maps to communicate the cases of COVID-19. Let's use this dashboard. Let me bring it to the shared screen. This dashboard technology is using GIS in the back end to display how the world or how US gets involved with the COVID-19 spread. And here, let's go to admin boundary defined by the state. Let's find Indiana, since this is Purdue related. I guess most of you are familiar with where we are at Indiana. We are not on the top, which is a good thing. My screen got frozen at a certain point. Okay. Let's zoom to Indiana, somewhere here. So on this map, it displays all the counties for Indiana. And if you click on each county, for some reason, my screen is really slow, you can see the case number and the death number. And here, as in Tippecanoe County, we have more than 1,000 cases already. And you can switch between different tabs to see the active case. This layer might take a little bit time to load. It's taking long on my computer, but I'm sure each of you has an opportunity to check this dashboard already. And on these panels, you can see different measurements. You can see the global deaths by different countries. Here is a graph showing the distribution of number of cases by time. And you can switch between different tabs to see daily cases, daily deaths, cumulative cases, different details. And this dashboard is literally using a GIS technology. For most of our GIS students, it doesn't really take long for them to develop a dashboard like this. But the unique part of this Johns Hopkins dashboard is they were able to aggregate the data collected from different data sources into one dashboard. My colleagues at Johns Hopkins University shared their story. It's literally initiated by a GIS student a grad student who knows GIS at a lab. They discussed with the professor, and the professor is really supportive. So they started this thing sometime around February, when COVID-19 was still a big thing at China. And later on, unfortunately, US started the cases. So this dashboard becomes so popular, and in the libraries, my colleagues is supporting the back end, and soon they realized this dashboard gets more visits than they expected, and they have to work with the platform provider to provide a stable environment so that more users can use this dashboard. So that's a story of how GIS can be used in our everyday life. And in addition to a dashboard to communicate the COVID-19 cases, there's another dashboard I want to show you here is developed by the major company who is producing the GIS software. It's called ESRI. A staff member at ESRI FYI developed a different view of this map. They still use the same data source, but in this case, they want to show where the COVID-19 trends are. The dashboard I just showed you a moment ago is about the total number of cases, but probably you are interested to see at your county, what's the trend are? Are we increasing the number of cases or are we decreasing? Are we getting better? So this map or this GIS visualization show you the answer to this question. Still, I assume you're familiar with Indiana. I will zoom to Indiana. In this map, here, in this map, they classify the counties into 5 categories as labeled here, based on the total number of cases, the increased number of new cases in the past 2 weeks, and the total population in that county. If there's just some new cases emerging in that county, they classify that county as emergent or labeled in light purple. Here around us, we even don't have emergent. I guess most of the county already got the COVID-19 cases long time ago. And if the case were not controlled well enough, if we have increasing new cases a lot in the past 2 weeks, it's categorized as spreading. And if the new cases is completely out of control according to the mathematical equation, the county is classified as epidemic. Of course, if the county starts from the emergent, but a few new cases were well controlled, the county is classified as controlled. Or if there's no new case in the past 2 weeks, the county is classified as the end stage. So from the map, you can see, unfortunately, most of Indiana counties spreading or epidemic, except a couple counties here, is under control. In our typical county, you can see it's not that bad. It's still spreading, but not at the epidemic stage. And this story map tells you different tabs. In this tab, it gave you the map about days since last new case. I would assume most of the counties we see the new cases every day. So the days since the new case is probably 0 or 1. Slight light yellow, as you can see from the map. But the good news is there are some counties in the United States kind of have this greenish color. It means that there are some counties like we didn't observe the new case for more than 10 days or around 20 days. And this star map have a lot of tabs telling you different aspects of COVID-19. Here is another map. One of my favorites. It's a really good visualization scale. It combines the number of population and the new COVID-19 cases together. I usually read the map starting from the legend. As you can see from this legend, the color of each diamond shape means the total population in that county. The reddish or darker red means we have a lot of people in that county. Toward blue or yellow means we have less people. And the size of this diamond means recent case counts. So as you see a lot of big cities, toward the red or dark red color means we have a lot of people in those counties got the COVID-19. There is a lot of people there, and they tend to be big means there are a lot of new COVID-19 cases. However, maybe we need to pay some special attention to some big blue diamond, some counties around here, around Florida or Texas. It means we don't really have that much population here. According to this legend, the population size might be relatively small. but we still have a big shift, means we still have lots of new COVID-19 cases. So probably these counties, we need to pay special attention, make sure there's enough medical providers there, make sure people are safe. So that's one example of how GIS can be used in communication of COVID-19 or in analysis or prediction. And some people take GIS in another way, say how people are reacting for COVID-19 cases. This map is collected by the data collected from Unicast. They are collecting the mobility data based on our mobile devices, since nowadays we are getting into the habit when we get out for shopping, for work, or anything, even when you take a walk, probably you might take your mobile device, your cell phone with you, and this company is collecting that data to estimate how well people are doing in terms of social distancing. And based on how far people have traveled, and based on the location people have traveled, they are giving the scores of how well we are doing with social distancing. Since the national map loading might be low, I will just zoom to Indiana. The score range from A to F, as you can see from this legend. Take it easy. I know we are in a reopening status, so maybe a lot of counties now with the social distancing measurements, we are getting F or D minus. Taking Lafayette as an example here, we don't really have a good score. It's because the average distance traveled here actually increased by 3% in the last 2 weeks. But the average visitation to non-essential locations actually decreased. So this score is like more complicated. I won't go into the detail of how they calculate, but they are measuring how well we are doing under the social distancing order. And the last map I want to show you here about COVID-19 is another company. They collected business information data. The company is from SafeGraph. They have all the location points for all the businesses in the United States. Again, a national map might take a really long time to load because there are so many businesses here. I want to zoom to the county. We are all familiar where Purdue is. Once we zoom in, we'll see the business locations here. And from the legend here, you can tell, legend, different color of these points means different types of business. Take the first one as an example. The red one means restaurants and other eating places. If you check all the red points, you know here are where the restaurants are. And the blue means offices of physicians. And the size of these dots means the number of people visited here. You can see we have a lot of visits somewhere around Purdue. And here, this big square, big diamond is the Columbia Park at Lafayette side. And at West Lafayette side, there are also some big diamond around big shopping centers. Here, I think it's Meyer and Menards and Walmart somewhere here. You can see how many customers each store gets under COVID-19 situation. If you click, some reason my web page is getting slow here. If you click, you can also get estimates of how many people visit around the different days, around the different timing. And all this information are organized by geographic information, and they can well communicate the information to our audience to show what happened to people around us, around the world, what happened with COVID-19 situation. All right, enough COVID-19. Let's talk about something else, something fun. Something happened at Purdue campus. So in my job, I work with geographic information to help people with their research. how geographic information can be applied to research. So in my view, I mainly helped in several of the following areas. Number one is climate change. People use geographic information to map the temperature and precipitation. They can use different models to model the climate change under different scenarios. They can model the sea level rise under the different climate change model, and they can also model how wildlife habitats are changed due to the climate change under different scenarios. I also seen great research happening on Purdue campus about how climate change have impact the ecosystem, how the forests respond to the climate change situation. Number two, the environmental studies. People can use the geographic information to map how the wildlife or different ecosystems distribute around the world. In my personal research, back when I was in grad school, my research was about the giant panda and the hemlock borealis, which is an invasive pest, how they distribute around the world, how the pollution happened, how it impacts people's everyday life. And number three, geographic information can be used to optimize the routes. As we say, we want to go to places, we check on Google Map or your phone, we know how to go, how to travel. And the companies can use this to optimize the routes. We can plan how a vehicle should travel in order to do a best delivery, how we should locate our warehouse so that it can reach most of the customers, but still in a relatively low price area. And also we can use maps to do the data integration. We can put different layers together, like in the COVID-19 situation, people overlay the population and the COVID-19 case, social distance, the store visit altogether to analyze, to predict what happens in terms of COVID-19. GIS can be really used in many different areas. It's until I work from the libraries, I start to have the opportunity to collaborate with researchers in very different disciplines. It's really inspiring to see how they use the digital maps in different disciplinary researches. And it's really eye-opening. So a lot of my work at Purdue, I think it's just to facilitate this geographic information application and to inspire students to think spatially, to use these spatial information to solve their research problems. In terms of a career, if a student take a geographic information course or take a geographic information certificate program, they can benefit a lot. It's not just trained to be a plain GIS specialist, a GIS analyst. They can use GIS in many different occupations. According to the Bureau of Labor Statistics, they predict there is a growth of 35% a year with a shortage of training people to fill the jobs in GIS. The demand is really growing. I have a really exhausting list of different jobs which might need GIS. Here I only pick a few, I think, interesting ones here, but already it's occupying the whole slide. For example, in agriculture, as you might know, the precision farming really need GIS as a tool to plan for plant the seed, for irrigation, for fertilizer application. The companies like John Deere is really using GPS and GIS system to help the farmers for a better farming practice. They can use it for like water stress analysis, crop yield analysis, disease control. It's really helping them to improve the yield. In the ecology research, as I mentioned, we can have the Earth observatory from NASA, NOAA, different federal agencies have collected enough amount of data for us to start study the ecology of different phenomena. In disaster recovery, we have the alumni who's working with Red Cross. We met together to discuss how to use GIS for shared operations. We can also use GIS to predict the risk. We have excellent researchers at Purdue to use GIS to risk the flood risk for to model the flood risk for United States nationwide. We can use the GIS to search and rescue lives after whatever disaster happened. In the area of archaeology, we already have a group of excellent professors working in GIS for field survey. Libraries is maintaining the database for them. They collect the data in the field using their mobile device, and all those data can be synced with our library database immediately when they connect to a Wi-Fi. And we can use GIS to do the site prediction so that they can plan their evacuation. And we can also use GIS to scan the text materials they have. GIS can help them identify the place names in all the text materials, then create a map based on those text materials. In architecture, I know in landscape architecture, students are using GIS to do geodesign. GIS can help them to predict the solar exposure, can help them to predict different scenarios for development planning. It's really a great tool. It also tells you where population are, what's people's preference. So it can integrate different things together. For business, people are using GIS to do the fleet management. They use GIS for store location selection or property appraisal. There are different ways GIS can help. And for aviation, we have students and faculty using GIS to do airport management, flight path mapping, and air traffic control is really a handy and great tool there. For crime, people are using GIS to map the crime incidents. They analyze the crime patterns based on space and time so that we can make sure to have enough police patrol in the area of concern. And there's also a term forensic GIS. People are using GIS to do different crime analysis. I do have students have interesting projects in these areas, but due to the time constraint, I won't go into the detail. But those are really exciting opportunities. I think one great opportunity at Purdue is we have the new School of Information Studies. It can integrate the geographic information in different disciplines. Traditionally, in many universities, GIS is usually taught by the Department of Geography and is taught to the geography students. Thus, they lack sort of collaboration opportunities with disciplinary research team. But now at Purdue, we have the School of Information Studies. Geographic information can be integrated into many different disciplines. Any questions so far? If not, I will advance the topic to the next topic. I will show you some sample projects happened at the Purdue Libraries and the School of Information Studies. It's basically the small GIS projects my team have worked on just with the library and School of Information Studies background. So the number one project is a collaboration between us, the GIS team here at School of Information Studies, with a professor at agronomy at Purdue University. And the app is called IC. It's a mobile app. You can download this app from iOS or Android App Store. It's The whole name is called Soil Explorer Integrated Spatial Education Experience, and the icon looks like this. So this professor has a really great idea to teach soil. Traditionally, soil is kind of mapped in this way. As you can see from this map, here is the polygon of soils. If you zoom in close enough, if you can see the details, each polygon has a code. From this code, hard code, you can check what's the property happened on this soil polygon. It can tell you if it's a sandy, loamy, or clay-like soil, how it feel, and what's the depth of the soil. If you think it's boring, it's not enough yet, let me show you how the Indiana Soil Survey looks like. Literally, it's a pile of the soil survey for Indiana. It's just for one state. It gave you a really great in-detailed map of soils in Indiana. But just imagine as a professor, if you need to teach your students about all these soil information, how overwhelming it will be and how the course will look like. So this professor has a really genius idea. He wants to marry the soil map with what we see in the field with the soil, and he used GIS as a teaching tool to accomplish this. So here he developed really great soil maps. On top, the color means the soil property. Yet, instead of using this traditional color scheme, he used a very genius color scheme to show the wetness of soils, like around the river area might be wet soil, just as our initial thoughts may be like blue means wet, and on top of these soils might be relatively dry. Anyway, I'm not an expert in soil, but here's just my interpretation of the color scheme. But to make it more interesting, he overlaid this soil information with the topography, or in our GIS terminology, it's the hill-shade background lay on the back of this soil. So from this map, students can not only see the soil property, but they can connect the soil with the landscape. As you see, there's rivers here, must be really low area. That's why the soil is relatively wet. And here on top of these kind of relatively plateau area, I shouldn't call plateau in Indiana, but relatively high area, the soil might be different and the soil change because of a landscape change. This way, students not only learned about the soil information, they also learned why it's this soil. It's because the landscapes are different. And here's also a website, soilexplorer.net. If you are curious about how it look like, but don't want to install the app on your mobile device, you can go to this website. Here I'll show you. Here you start with select region. We have worldwide soil map, but if you zoom into a more detailed area, you can see more detailed soil information. As you see, this project got collaborations in many states in the United States already. These states are all using this tool to teach soil for their students. And it also expanded to Kenya and Peru to benefit people over there. Here for this demo, let me zoom to Indiana here. This map shows the soil, dominant soil parent material information. And I'm not a soil expert, but I can already check with how the soil look like in my backyard. I can click on the soil and it tell me what's the soil parent material, or you can open the legend to learn different soil parent materials around you. Dr. Deborah Schultz, the collaborator I have at agronomy, he gave workshops to not only to college students, but also to K-12 students, to gardeners, also to soil professionals. They all find this is very interesting. Gardeners can find immediately how the soil look like in the garden they are interested and tell what kind of plants is good for them to plant. In addition to soil parent materials, there are different soil properties you can choose from this too. Here, maybe soil drainage class make more sense to somebody like me who don't really have a lot of soil background. Here, Dr. Darashaw's classify the soil based on different drainage classes from really well-drained soil in red, brownish color to poorly drained soil. As you can imagine, poorly drained soil, there might be more water maintained there, and a well-drained soil, not that much water. You can zoom into different areas and tell how the soil look like so that you know how to deal with the soil in your garden, or if you have a wet basement or relatively dry basement. It's a very useful, interesting tool, not just for soil teaching purpose for the students, but also for everyone who's interested in planting anything or care about the soil. And this year, due to COVID-19, we might not be able to bring students to the field trip. So the next stage for this project team is to develop something good for students without a field trip. So here is a picture how we usually have our field trip. Instead of taking the whole pile of Indiana soil survey maps, now we have digital maps on the mobile devices. Students can just take the iPad device in the field. They can zoom in to wherever they traveled. There is a GPS, like the blue dot thing, show where the users are on the map, and students can check the soil immediately. Then in the field, they can dig a soil profile like this to learn more detail how the soil look like in the field. But this fall, due to the limitation of travel, we cannot have a large group of students travel on a bus like a Euro like this. So what we are proposing to do is to develop a virtual field trip experience still hosted on this soilexplorer.net website. Students, if they cannot travel that far, they can still stay at home, take a virtual reality view of the soil properties in the field. Thus, they won't feel miss too much about the real in-person field work. They can still dig around Purdue in some certain designed labs, but for some far labs, like we travel to the north part of Indiana or really far south of Indiana, they can use this virtual field trip to learn more. So I look forward for that new development. Another example we have at Purdue Libraries and School of Information Studies is like we can use GIS to study our own institution repository. For some of you, if you know, we have a Purdue EPUB platform. This is our institution repository. It's one place to host all kinds of Purdue scholarly research here. It's a one umbrella for long-term preservation and for access purpose. Everybody around the world, they can use this open access tool to access Purdue's research. And from 2014, this platform started to have a new feature to record the location of where the readers are. If, for example, if you are somewhere here in California, if you download a publication from Purdue EPUB, probably we will be able to tell there is a user from California downloaded certain publications. As a GIS specialist, I'm very interested in this data source. So what we did is we collected all the users' information and compiled them into a map. So to my surprise, I can see the open access by Purdue Institutional Repository is really reaching to people toward the whole world. It's not only used by people in United States, not only by Purdue, but also by a lot of people from European countries, from India, and from many other countries. Don't be frustrated if here it's like we don't really have as red as European country or United States. As you can imagine, in some part of the world, people are not speaking English. Reading English might have some limitations for them, but they still choose to download our research records for research purpose. That's great. And my current study is really taking into details of who are using our institutional repositories. So now we break them down into 6 categories. We have the educations. It means from the educational institutions like Purdue, other universities. We have the most of download from education institutions. Their interests like in humanities, education, and engineering publications. But the second biggest group is actually from commercial institutions, different with education institutions. Commercial institutions in this line, they have most of the downloads focus on engineering parts. Traditionally, we measure the impact of a publication usually by the citation. If this author gets more people cited, it might mean this publication has more impact to other researchers. But this readership analysis based on the GIS really tell us, in addition to researchers from education institutions, we do have a lot of people from the commercial institutions who care about our Purdue's research, and especially in engineering field. And consider this commercial institutions might be the place to carry the actual technology forward to make them into the real products. I think this impact is really valuable. It's really something interesting to tell. And it's also an interesting story to share with our researchers to encourage them to make more their publications as open access so the rest of the world can take advantage of their research. And another interesting story I want to share here is a collaboration between the GIS team and the archives. We worked on the Purdue campus facilities and buildings historical database. The Purdue archives have a lot of great collections about all aspects of Purdue. And my favorite one, as you might be able to tell, is about the old maps. So how the old maps can meet the modern technology. In Purdue archives, they have collected a lot of historical Purdue campus maps, beginning in 1874 and ending in the most recent years. They have more than 200 maps in 9 folders, 2 big boxes. So what they have is like in the old days is campus map from Purdue University student handbook, and later on in the 1900 to 1930, they have the campus map made by Purdue's School of Civil Engineering, and from 1940s is Bulletin of Purdue University, and from 1950 to now, it's basically the Welcome to Purdue map. This is a relatively old map, and here's a walking tour of the Purdue University. If you come to Purdue in recent years, like me in the past 10 years, maybe that's kind of map you are familiar, or this map. What we did is, and I forgot another interesting map. They also have a lot of other interesting maps, like this old maps, really genius, I would say. They kind of combine a traditional map with like nowadays Google Street View. So that's when you take a map, look for a place, you can tell how the building look like when you walk around the area. One of my favorite maps. So what the GIS team did is we take all these maps, we georeference them, and digitize them so that they stay in a big geospatial database like this. We have lots of layers mapped from different years. Then we overlay them together to make like how Purdue campus change over years. So here's an animation of how Purdue campus grew from the initial several buildings Like we have the stadium, we have lots of new buildings, we have the student dormitories, and it's a really exciting map show the growth of Purdue. And this database is alive online now. It's the efforts by the libraries, IT, the archives. If you want to bring some memory back to Purdue campus, please go to this website. You can still check by different years. Here's a time slider on the bottom. And you can zoom to the buildings you might have some memory about. So here, let me click on this building. It's the Purdue Memorial Union Club. It has two shapes because there was a major renovation around 1955 here. We have a map from 1940, the smaller shape, and we have a bigger union from 1955 to now. And if you want to know more information about this building, let's bring you to the more information page about this building history, different photos collected by the archives. I think it's really a nice tool to help us remember what happened at Purdue campus and my personal favorite at archives. And another more recent application of GIS with Purdue Libraries and School of Information Studies is about the new building we have. As many of you, if you have visited campus in the recent few years, you cannot miss this new building. It's the Wellness Active Learning Center building, located really at the center of the campus. And here's a map of where this building located. Here, this small dot is the bell tower, if you remember as my background here. And this building is located right across the street of the bell tower. It has 3 floors plus the basement. It has 27 active learning classrooms and also a lot of library study and collaborative spaces. And it's open 24/7. Of course, due to the COVID-19, this hour has some modifications, but in normal days, it should be 24/7. And the research question here, how GIS can help with this new building, is we want to study where is the best study space for students, where students like to spend their time there, and what kind of furniture or technologies students might like, so that we can better serve the students in the future. Now, here is an example of how the first floor plan look like. We do have a lot of state-of-art active learning classroom designs. We have the boiler classroom, like this big, with a lot of collaboration space. We have the scale-up classroom, and we have performance classroom, like big theater-like classroom. Here's how the boiler classroom look like. It's really nice collaborative environment for active learning. Of course, due to COVID-19, there are new standard operations here. I won't go into detail. And here's a picture of the reading room. And here are different library collaborative spaces. Here's the computer, and here's the first floor meeting and the collaboration space, the basement, and the different designs of settings. We are interested to know what kind of settings students like to use the most. So collaborated with the director of assessment and the building deputy, we designed a GIS interface for people to start collect the observation data. So we have the staff members scheduled around some certain daytime and also the evening hours to collect the data. The staff members need a login interface to log in, so we know which staff member collects which data. Also, we don't want to expose this data to the general public. And here, if you're holding this mobile device in the library space, you will see a blue dot showing where you are so that the staff member can know which room they are at. They can just click on this room and of course, from here, you can see we can pick different libraries. It was initially developed by for the walk, the new building, and later on it's implemented also in Hicks and Parish Library. And here we have the different classroom. We can record different student activities, number of students, what they are doing, are they studying, are they using computer, are they collaborating on certain projects here. After room's information is collected, this room will be shaded like this. You can revisit, see if there's any mistake, or if it's a team data collection effort, you know which room has been collected by the team member. And after they submit all these, we develop a dashboard for all the administratives so that they can see how many students have been in that room. And they can query by different room, they can query by different day, different time period, and they can have estimate about how many students are there. We also have the daily tabular-based report for the building deputies so that they will know what's going on in that building and will know what kind of furniture, what kind of technology are preferred by students. It's a really handy tool for us to do the evaluation. So until now, if you are interested to learn a little bit more about the GIS, or if you already know GIS but want to sharpen your skills for GIS, I want to introduce you some learning resources offered by School Information Studies and the Purdue community. The courses, Purdue has several courses taught by different colleges, College of Agriculture, College of Engineering, College of Liberal Arts, and School of Information Studies, mainly initiated by me. We start to introduce GIS to students in these areas. But a related course, maybe not really teaching GIS directly, but using GIS in certain aspects exists in many, many different departments. If you can find your departments here, that's good. Probably you already have taken some course related to GIS. And since it's a really long list, I didn't really list every department here. If you're interested, feel free to check with me. I'll be happy to get you started. And in the libraries, we do provide instruction. We provide consultation. If someone wants to start with GIS but don't know where to start with, feel free to ask us. We'll be really happy to help you. And we also offer workshops to get people started or to introduce a new update of the technology. We offer independent studies if there's no course fit for your purpose. We offer guest lecture for courses which might use GIS, and we also offer full credit course. In the coming semester, the exciting news is there will be a Purdue graduate certificate program in GIS. It will include 4 courses, and the first one is Introduction to GIS. It can get you started with GIS. And in the advanced topics, students can choose any direction they are interested, probably in big data, data science, probably in remote sensing, probably in spatial statistics as the major topic for their advanced study. They can choose the application course. As I mentioned, many departments are already offering application courses in different fields. They can choose any one of those. And finally, they need to complete a project with all the information process, like how to collect information, use information, present, and communicate geographic information from the School of Information Studies to complete this certificate. It should be easy, it should be designed for everyone. And with this certificate, it really puts the students in an advanced position in the job market. Other learning resources in the libraries, we have our developed lab, Data Visualization Experience Lab of Purdue on the 3rd floor of Walk building. We have designed this lab specifically for GIS and visualization purpose. We have the monitors specially designed for learning GIS purpose, and it's open from 7 a.m. to 2 a.m. It really provides a flexible learning time for students. Either you like to work in the morning or work really late in the evening, you can always find time to work in this lab. It has been a great learning environment. And we also have a big visualization wall here for students interested to work with big maps, especially for those old scanned maps. It's not intelligent enough. Like if you type a street, like a broad street, you can see it. You have to check on the map and see where the street is printed. This big screen is really great for those students to work on their projects. And finally, if you're interested to meet the Purdue GIS community in person, come to campus at a certain time, not this time during COVID-19, but every fall we host the Purdue GIS Day Conference. These are some photos we had for the 2019. This year, due to COVID-19, probably we won't have in-person meetings, but in the future years, definitely check with us. Every fall around early November, there should be a Purdue GIS Day Conference happening, and we have a lot of interesting presentations. We have enough student poster sessions. If a presentation or poster is not interesting enough, you can see some showcases. We have really cool projects showing here, and a lot of opportunities for students to get an award, get a presentation opportunity. That's really great and interesting. So finally, if you're interested, feel free to contact me. I can be reached by this email, kongn@purdue.edu. Thank you so much for participating. If you have any question, feel free to ask at this moment, or feel free to email me at any time in the future.